Hello, everybody. So I provided you with these practice problems the other day, and I had a question about how did I arrive at my t-values. As you saw, I provided the answers already. What I would do if I were you is I'd work these out first before looking at the answers and before hopefully looking at this video, but I'll just show you how this is done. First of all, this is an independent samples t-test because we have two independent groups. We have males and females, two different sample sizes. We have the mean, standard deviations. Basically, we have everything we need to complete the task. So what I'm going to do here is to show you how I arrived at the critical value. I'm not going to do the problem. I did them already, but they're in a separate document. But let me just show you how I did this. So we're using the conservative method for degrees of freedom. That's the smaller of the two groups' degrees of freedom. So males have N of 432 and females 512. So it's more females than males. With 432, the degrees of freedom would be 432 minus 1, or 431. 512 minus 1 is 511. Which of the two is smaller? Well, 431 is smaller. So that's my smaller of the two degrees of freedom. If you look at the work that I did, let me expand this to a single page view and increase. So here, I have my t-value with 431 degrees of freedom being my critical value of 2.364. So how did I get that? If you go to the table, first of all, I need to look for 431 degrees of freedom. And I don't see 431. I see 100 and I see 1,000 degrees of freedom. Neither of those fit. I'm a little bit closer to 100 than I am to 1,000. So I have a couple choices, either this row or this row. Now, let me go back for a second and say what my alternative hypothesis is. Is it one or two-tailed? That's a tough question, but and I noted this in the prelude to the assignment or the assignment description. When you make your choice, you're going to take a look at the data. What did the data tell you? Here we have the data in advance. It's not like we're collecting data, so we don't know we're going to find out. We look at our data and we see females have a higher mean social anxiety than males do. So to me, why would I not have my alternative hypothesis be that the mean of mean of males is greater than the mean of females? That would make more sense to me. So that's clearly a directional hypothesis. I mean, I could, and there's nothing wrong with doing a two-tailed test for saying males and females differ, but not propose a direction. But why would I do that? First of all, one-tail alternative hypotheses are more powerful. That means you're more likely to reject the null hypothesis than a two-tail. Plus, I have data, and they're clearly showing me that females scored higher than males. Only thing, we don't know if this is statistically significant. So we're going to use a one-tail test, and I also told you to use an alpha of 0.01. It's in the instructions. So let's go back here to a one-tail test. So it says one tail, 0.01. By the way, that's the same as a t with 0.99, covering 99% of the distribution, but you're not going to worry about that because if you're not familiar with that now, you need to go back and look at how we arrived there. But let's look at the one-tailed alternative hypothesis, and I'm going to go all the way down here to the end. And I have several choices, right? I have either 100, 2.364, or I have 1,000. With 431, I'm closer to 100. And it's a good choice when you're somewhere in between to always go with the larger value. It's more conservative. It's harder to reject the null at 2.364 than it is at 2.330. So I chose this one. So that's how I arrived at my critical value. So you can take a look at that. I also just talked about the conclusion was to reject it. Yep, to reject it. And here's just a reminder, this is our equation. You have to square the standard deviations to get the variances and do all the work. We got minus 4.2 here, which is larger than our critical value of. Well, remember I also said take the absolute values, because really, if we're doing something where we have a negative t-value, this critical value would be minus 2.364, but it's okay if you just look at the absolute values. The absolute value of negative 4.2 is 4.2, and that's greater than 2.364, so you'd reject the null hypothesis. That's just a quick summary of what we're doing. Thank you very much.